Welcome to Brain Vision.
In this problem, we're going to talk about several topics concerning one-dimensional motion. So let's say that we have a particle that is undergoing one-dimensional motion where the x-coordinate is given by a certain function x of t. Then we can calculate the velocity of that particle as dx dt, the acceleration as dv dt, or d2x dt2, that is the second derivative of x. Also, the force applied on that uh, object is equal to the mass of the object times the acceleration. The kinetic energy of that object is the mass times v squared over 2. And also, we need to know that the power is the derivative of the energy with respect to time. Okay, so these are the concepts we're going to use in our problem. So basically, what we have is an object that has a mass of 4 kilograms that is traveling with a trajectory that is given by a function x of t that is equal to t plus 2t cubed. And in question A, our goal is to find the kinetic energy of that particle as a function of t. So what I'm going to do first is to calculate v, and v is dx dt. So it's the derivative of t plus 2t cubed. The derivative of t is 1. The derivative of t cubed is 3t squared. So 3 times 2 is 6. So the kinetic energy is the mass times v squared over 2. The mass is 4. Then we divide it by 4 and multiply it by 1 plus 6t squared squared. So the kinetic energy is 2 times 1 plus 6t squared squared in joules. In question B, we have to calculate both the force and the acceleration on that object. Let's start with the acceleration. We know that the acceleration is the derivative of the velocity with respect to time. The velocity is 1 plus 6t squared. The derivative of 1 is 0. The derivative of t squared is 2t. So the acceleration is 12t. And the force is just the mass times the acceleration. So it's 4 kilograms times 12t, so that's 48t joules. I'm sorry, not joules, this should be newtons. Then in question C, we have to calculate the power delivered to this object. So notice that the change in energy of the object is the change in kinetic energy because the energy of the object is the kinetic energy. So the power will be the change in kinetic energy. Now remember that the kinetic energy is equal to 2 times 1 plus 6t squared squared. So this is 2 times. Now I'm going to apply the chain rule for for this object here, for this expression here. So I'm going to differentiate the exponential first. So actually not the exponential, but the 1 plus 6t squared squared. It's 2 times 1 plus 6t squared times the derivative of what's inside the parenthesis, and that is 12t. So this is equal to 48t times 1 plus 6t squared. This is in watts. And finally, in question D, we have to calculate the work that uh, is exerted over the system between the times of 0 and 2 seconds. Okay, so notice that the work is equal to the integral of the power exerted over the system times t from 0 to 2. Now the integral of 48t times 1 plus 6t squared dt from 0 to 2 is equal to the integral from 0 to 2 of 48t plus 288, this is 48 times 6, t cubed dt. So w is equal to the integral of 48t is 24t squared plus 288 divided by 4, that's 72t to the fourth from 0 to 2. And this is equal to uh, 24 times 2 squared plus 72 times 2 to the fourth. So W is 1248 joules, which concludes our exercise.